Welcome. My name is Catherine Medina de Villiers, and today I have the pleasure of teaching you about random variables topic 135, 1.3.15. What will you learn today? Well, today we're going to talk about how we use random variables or look at the results of random variables to determine possibilities. We use a lot of randomization to also help us simulate real world phenomenons that out there, and we'll get to that later. On the AP-CSP exam, randomization is expressed one with parameters like you'll see in the text form with an A comma B, and also expressed in block form with A comma B within a block. What you need to take away from this is that the range of numbers being expressed as A and B are inclusive. So for example, if you can look here, I have random and then I have 1 comma 3. That's going to mean that that piece of code is either going to provide you with a return of 1, 2, or 3. So that is the range, and the numbers are bookends, but inclusive. So let's start hopping through here and let's look at some examples. And again, randomization, we see it a lot in day-to-day activities like game of chance. Actually, you'll actually see it show up in video games programming if you're ever getting around to programming games, especially with your create task. You may want something to fly across the screen randomly. So here we're looking at games of chance like marbles or a spinner. So how do you simulate randomized scenarios? And that's what we're going to be looking on further. And again, here's an example of using a random piece of code in block form, 1 comma 6, and it's going to only return one of the numbers in the set 1, 2, 3, 4, 5, or 6. Another thing to emphasize is that this is discrete. Randomization will provide you one number at a time. So let's look at these examples. So here we have answer 1. It's going to go ahead and be assigned to random 0, comma 2, meaning it's going to be assigned to a possible number of 0, 1, or 2. For answer 2, the range is 1 to 5. What do you think the possible numbers could be? If you said 1, 2, 3, 4, and 5, absolutely correct. But answer 3 now is being assigned the possibility of what are the possibilities, the sum of what's coming out in answer 1 plus answer 2. So what would be the range, the possible range that answer 3 could be? So pause your screen and we'll be back in a second. Well, welcome back. And if your answer is 1, 2, 3, 4, 5, 6, or 7, you nailed it. Great job. Oops. So when you think about it, the lowest number you can get from answer 1 is 0. And the lowest number that you can get for answer 2 is going to be 1. So you'll add the lows and you're going to get 1. And think about it in the sense of the highs, as I call it. So the highest number out of answer 1 is 2, and the highest number out of answer 2 is 5. Add them together, it's 7. That's the high, the possible high you're going to get. So 1 will be the lowest, 7 will be the highest, inclusive, and then you just fill it in from there discreetly. Let's look at another problem here. You've got a die that contains 6 sides, right? And so you're looking at a sum here of the numbers that you're adding up after each roll 3 times. So you're going to roll the number, excuse me, roll the die, get a number, roll the die, get a number, add it to the first number, roll the die, get a number, and then you're going to add it to the other 2 numbers. So I'm probably giving you a little too much hints here, but take a look at this and we'll be back. Okay, if you said A, great, because it is, because every time you roll it, you're not going to get the same number, or hopefully you don't, okay? Sometimes that does happen. So you can't pick C because C is saying, I'm going to multiply that one number that came out 3 times. You're saying basically that you rolled it 3 times and every time you got the same number, and that's not what's happening. And then for B, the random is from 1 to 18. You're basically then saying your die has a side with 18 dots or 10 dots. No, so that's why B doesn't work out either. So hopefully you're getting this. Let's go to the next one. Here's a problem working with random number generators with a piece of code. I want you to take a look at this one, but watch it here. Be careful because your I is starting off with initialization of 2. I'm repeating until I is greater than 4. So put it on pause and I'll be back. Okay. Did you say C? Hopefully you did. And hopefully you're able to nail it quickly. Because the first time through here, if you look, pick gets random 1 comma I. Pick is only going to be able to be either 1 or 2 the first time through. So the first number on the set of numbers that you're generating here in a row, you can't have 3, only 1 or 2. So right off the bat, just with that one pass through on the code, C is out of there. Okay. Now, just to kind of alienate things a little bit better, if you look at B, 4 is still a possible number at the end because the repeat until is I is greater than 4. So it does have a 4 on that last run through that it still can pick through. Okay. Because it's still meeting the condition. You're not greater than 4. So my I can be 4 and be part of one of the numbers on that last pick there. Okay, let's recap. Random generation, it's great. It's reusability of code. We get to use it on the exam to help create some simulations here. You're going to look at a range of A comma B. Remember, the numbers are inclusive, okay? Each reset of randomization is equally likely to occur. We help use this randomizations to program simulations that are upcoming attractions. So again, what you to take away, for generating random values, we use these expressions of code that have been given to us. Essential knowledge, remember you can see them in a comma B or in a block code form. I really hope you enjoyed this lesson with using randomization, and I hope to see you in the second lesson on this. Bye.